Two particles are prepared together, then separated. Measure one, and the other responds. It does not matter how far apart they are. Einstein called this spooky action at a distance. The worry has always been the same: how does the influence get from one to the other, fast enough, across all that space? Temporal rate ontology does not answer that question. It dissolves it. In this framework, space is not fundamental. Space is a representational encoding of coordination patterns in a structure of ordered succession. It is something we derive, not something we are given. So when you ask how the influence crosses the distance, you are already assuming the very thing that is supposed to be derived. There is no gap for anything to cross. What is actually there is a directed acyclic graph of events, and the set of ways that graph can continue. Subsystem A has its admissible continuations. Subsystem B has its own. And now the only question that matters: does the joint structure split cleanly into those two pieces? Sometimes it does. If every jointly admissible continuation is just some admissible move of A, paired freely with some admissible move of B, then the joint measure is a product of the two separate measures. That is independence. Every combination is allowed. Nothing about A constrains what B can do. Entanglement is what happens when the joint measure refuses to factorize. The joint continuation measure cannot be written as any product of measures on the parts. The admissible futures of A and B are structurally coupled. Only certain joint patterns were ever permitted. Notice what this is not. It is not two separate things reaching across space to influence one another. It is one continuation structure that was never separable in the first place. And this is why the correlations do not threaten relativity. When the two outcomes agree, it is not because a signal passed between the detectors. It is because only certain joint succession patterns were ever admissible. The constraint is on what can be jointly realized, not on what one side transmits to the other. Nothing travels. Nothing is sent. There is no influence with a speed, because there is no distance for it to have a speed across. Now, is any of this testable? A framework that cannot fail is not physics. The framework predicts that entanglement degrades under gravitational constraint, at a rate set by the inverse of the local temporal rate. That rate can be compared against the value proposed by Penrose and Diossi. If the two disagree, for systems where both can be calculated, then this account of gravitational decoherence is ruled out. That is a genuine risk, and it is meant to be. Entanglement is not a link across space. It is a joint continuation structure that never came apart.